Hi, everyone. We're a few minutes early. Did anybody have any questions for us to get started with today? Did anybody have any questions? Okay, so yesterday we had gotten started on this section. This was section 6.2, the sum and difference identities. And so we have the formulas for the cosine of A plus B, the cosine of A minus B, the sine of A plus B, and the sine of A minus B. And we looked at finding the cosine of 75 degrees and the cosine of 15 degrees. We looked at finding the sine of 7 pi over 12 and the sine of pi over 12. And then we had simplified a couple of expressions. We saw that there were a couple different ways to do each one. And if you guys don't have any questions, then we'll go ahead and take a look at this next problem. It says that we want to find the sine of A plus B, and we're given that the sine of angle A is equal to -3/5, and that the cosine of angle B is equal to -1/3. Okay, so let's see. In order to do this, we're going to need to remember the formula to find, we're trying to find the sine of A plus B. And the formula tells us that that'll be the sine of A times the cosine of B plus the cosine of A times the sine of angle B. And we know a couple of those. We know, sorry, got just a few more people to let in. There we go. We know the sine of angle A, so we'll be able to plug in the -3/5. And we know the cosine of angle B, we'll be able to plug in the -1/3 there. And we need to figure out the cosine of angle A and the sine of angle B. We are told that angle A is in quadrant number 4, so we know that its cosine will be positive. We can go ahead and figure out what that is. Okay, so I kind of set up my little right triangle in quadrant number 4. We know that the sine is -3/5, so the y value is -3 and the hypotenuse is 5. So we'll do -3 squared plus x squared equals 5 squared. And that gives me 9 plus x squared equals 25. So that tells me that x squared will equal 16. So x could be either 4 or -4. But since it's in quadrant number 1, x will equal 4. And so that tells me that the cosine of A will be 4/5. And then for B, we're told that angle B is in quadrant 3, and we know its cosine is negative 1/3. So the x will be a negative 1, and the hypotenuse will be 3. So we'll have negative 1 squared plus y squared equals 3 squared. So we get 1 plus y squared equals 9. That tells me that y squared is equal to 8. So y is equal to the square root of 8, which is the same thing. Well, actually, hang on one second. We've got a slight problem. Y will be negative because it's in quadrant number 3, so it'll be minus the square root of 8. And so we get negative square root, or negative 2 square root of 2. So we have negative 2 square root of 2. And so that then tells me that the sine of angle B is equal to negative 2 square root 2 over 3, okay, because it's the y over the r. Anybody have any questions about anything so far? Okay, so now that I've figured out the missing values, I'm ready to go ahead and plug things back in. So the sine of a plus b, we know that's equal to the sine of a. We were given that the sine of a was negative 3/5. We just figured out, we know the cosine of angle B. We were given the cosine of angle B was negative 1/3. The cosine of A we found was 4/5. And the sine of angle B we figured out was negative 2 square root 2 over 3. Does that make sense so far? Okay, so now we can go ahead and multiply things out a little bit. Here we have 2 negatives being multiplied. That'll make a positive. I could cancel the 3 on top with the 3 on the bottom, but my other fraction will end up with a 15 on the bottom, and I'll need a common denominator. So I'm going to go ahead and not cancel out and write this as 3/15 so that I get a common denominator. And I have 3/15 minus, okay, because I'm multiplying a positive times a negative, that gives me a minus. And I end up with 8, that's from the 4 times the 2, 8 square root of 2 over 15. There's different ways that we could write our answer. I'm going to write it as 3 minus 8 square root of 2 over 15. Is that okay with everybody? Any questions on that one? Okay. Next, we want to check and see if this equation is an identity, which means that it's true for all values of a and b in the domains of the function, or a conditional equation, which means that it's only true for some values. So I'm going to kind of go ahead and suppose it's an identity. So I'm going to start with the more complicated side, that's the left-hand side, and see if I can manipulate it and show that it's equal to the right-hand side. If I can do that, that means that it's an identity. So I'm going to start with the top, the cosine of a minus b, over the bottom, the sine of a times the cosine of b. Okay. And now I want to think, what do I know about this? Well, we know a formula for the cosine of A minus B. Oh, sorry, we had a question. Why are we setting it equal to that identity? And would it be a plus 8? Okay, 8 square root 2 over 15. I'm getting a minus because I have this minus sign right here in front, right here, and this one has a plus. So when I multiply a positive times a negative, that's going to give me a minus here. Does that make sense? And then we also had, why are we setting it equal to that identity? Was that about the next example, the one that we just started with? So I'm assuming you're asking about this one. Okay, thank you. Well, so this is just the question, okay? And it's asking me, I need to decide whether it will be true all the time or only true some of the time, okay? So if it's an identity, it's true all the time. Otherwise, if it's only true sometimes for certain values of A and B, then it's conditional. And I don't know which one it's going to be yet, okay? So I want to see if it's possible to transform the left-hand side into the right-hand side, okay? And so for this one, because I have the cosine of A minus B, we've got a formula for that, okay? So I'm just going to remind you about the formula for the cosine of A minus B. That's equal to the cosine of A times the cosine of B plus the sine of A times the sine of B. So I'm going to go ahead and use that on the top on that example. Okay, so on the top, we have the cosine of A times the cosine of B plus the sine of A times the sine of B. And the bottom has stayed the same. It's the sine of A times the cosine of B. Does that make sense so far? All I did was I used my identity for the cosine of A minus B. Now what I can do, because I have a plus on the top, I'm able to split this up into two fractions. So I'm going to do cosine of A cosine B over the bottom plus the sine of A times the sine of B over the bottom. Okay. Now, notice my first fraction over here has a cosine B on the top and on the bottom. I can cancel those out. And my second fraction has a sine A on the top and a sine A on the bottom. I can cancel those out. So both fractions can be simplified. My first fraction is going to then give me the cosine of A over the sine of A. And then my second fraction is going to give me the sine of B over the cosine of B. Okay, and now the cosine of A over the sine of A, that's just cotangent A. So this is equal to the cotangent of A plus, and then the sine of B over the cosine of B, that's equal to the tangent of B. Okay, so I have shown that the left-hand side can be transformed into the right-hand side, and it doesn't matter what values of A and B we have, right? And so that means that it is an identity. All right, so we just proved the identity by starting with one side and transforming it into the other side. Anybody have any questions about that one? Okay, what would it look like if it was conditional? Well, let's take a look at the next one. So it's the same question. Is it a conditional equation or an identity? So let's see what happens if we start with one side and we try to transform it into the other side. So let's start with the left. So the sine of x minus pi over 2. We have a formula for the sine of a minus b. I'll go back to the front page and show you what that looks like. The sine of a minus b is equal to the sine of a times the cosine b minus the cosine of a times the sine of b. So we're going to use that identity right there. Okay, so this gives me the sine of x times the cosine of pi over 2 minus the cosine of x times the sine of pi over 2. Does that make sense so far? Now remember, I'm trying to see if it's equal to the cosine of x plus pi over 2. Next, what do we get next? Well, we have the sine of x. What's the cosine of pi over 2? Think about your unit circle. What do you know for the cosine of pi over 2? That's just 0, right? Then we have minus the cosine of x times the sine of pi over 2. What do we know about the sine of pi over 2 from the unit circle? That's just 1. So how does this simplify? Well, sine of x times 0 is just 0. So we've shown that it's equal to negative cosine of x, which is not what we were aiming for, right? We've shown that the sine of x minus pi over 2 is equal to minus the cosine of x. So that would be an identity. All right. Let me write that down. So sine of x minus pi over 2 equals negative cosine x is an identity. That's always going to be true, no matter what x is. And that's basically saying that the sine and the cosine graph are just shifts of each other, right? Which we know is true. Let's now take a look at the right-hand side. So let's start with the cosine of x plus pi over 2. And we're going to use the formula for the cosine of a plus b. That formula tells us we'll get the cosine of x times the cosine of pi over 2 minus the sine of x times the sine of pi over 2. We get the cosine of x times 0 minus the sine of x times 1. And so that tells me that we get minus the sine of x. So that's another identity. But now, are these two things equal to each other? Is the negative cosine x equal to sine x? That's our real question at this point, because we've simplified both sides of our original equation. Now we want to think about whether negative cosine x equals negative sine x is an identity or conditional equation. Okay, well, I can go ahead and multiply both sides by -1. Okay, so we can multiply both sides by -1 and turn it into cosine x equals sine x. What do you guys think? Is that always true for every value of x? I don't think so. Okay, this isn't true for every value of x. That's only true for a few values of x. So that tells us that our original equation will only be true for a few values of x. Okay? And that means that the original equation is a conditional equation. Anybody have any questions on that one? Okay. So next, we want to think about the tangent of a minus b. And we know the tangent of a minus b, well, we know the tangent of x is equal to sine x over cosine x. So the tangent of a minus b will be equal to the sine of a minus b over the cosine of a minus b. Whoops, I don't know where I came up with that. So on the top, I want the sine of a minus b. On the bottom, I want the cosine of a minus b. So I've got my fraction, I've got sine a minus b on top and cosine a minus b on the bottom. And now I'm going to go back and remind myself what those formulas were. So the cosine of a minus b, that's going to be the bottom. That's cosine a cosine b plus sine a sine b. And then the top, that was sine a minus b. That'll be sine a cosine b minus cosine a sine b. So the top of this becomes the sine of a times the cosine of b minus the cosine of a times the sine of b. And the bottom is the cosine of a times the cosine of b plus the sine of a times the sine of b. Okay? So now let's see what we can do with this. What I'm going to do is I'm going to take this and I'm going to divide the top and bottom by the cosine of a times the cosine of b. So it's going to get even messier than it already is. So I'll have the sine of a times the cosine of b minus the cosine of a times the sine of b. Okay, that was what I originally had on the top. And I'm going to divide that by the cosine of a times the cosine of b. I'm going to do the same thing on the bottom. So I have the cosine of a times the cosine of b plus the sine of a times the sine of b on top. And I'm dividing that also by the cosine of a times the cosine of b. Remember, you're allowed to do that. If you have a fraction, you can multiply the top and the bottom by the same number, or you could divide the top and the bottom by the same number without changing the fraction. Okay. So now that I've done that, because I have I'm going to just think about this fraction on the top. It's got a minus sign in the top. That means that I can split it up into two pieces. What's the point of dividing? Well, so that I can split it up into my two fractions and I can cancel some things out. So we're going to end up with a really nice formula for the tangent of a minus b. Okay, so how did we do that? We just divided the top and the bottom by the cosine of a times the cosine of b. Okay, so for example, if you had a different fraction, let's say 3/4, you could multiply the top and bottom by 2. That would give you 6/8. Or if you had a different fraction, I don't know, 50 over 150, you can divide top and bottom by 50 to get 1/3. Okay, so if you have a fraction, you're allowed to multiply the top and the bottom by the same thing. So here I multiply the top and bottom by 2, or you can divide the top and the bottom by the same thing. Here I divided the top and bottom by 50. Okay, so that's just something that you're allowed to do with fractions. So what I did was I divided the top and the bottom by the cosine of a times the cosine of b. And the reason I did that, okay, so here when we're working with numbers, dividing the top and bottom by 50 is how we can simplify, but it is something that you're allowed to do algebraically without changing the value, okay? And the reason that we're gonna do it is we're gonna end up with a really nice formula for the tangent of a minus b, okay? So hang on just a second and let's see what happens. So thinking about just the fraction on the top here, we've got a minus sign on the top, and that's going to allow us to take this single fraction and split it up into two pieces. Okay, so the two pieces that we get will have the sine of a times the cosine of b over the cosine of a times the cosine of b. So I just took the first part of the top over the bottom, and then the second fraction will be the cosine of a times the sine of b. That's the second part of the top, and then that will go over the denominator, cosine a times cosine b. Does that make sense how I took this single fraction and I split it up into two fractions? I can do the same kind of thing on the bottom. I'm going to take this single fraction and split it up into two fractions. So my first fraction will be cosine A times cosine B over cosine A times cosine B. And then my second fraction is the sine of A times the sine of B over the cosine of A times the cosine of B. All right, so I took the two fractions that were on the top and split it, the one fraction on the top and split it up into two fractions. And I took the one fraction that was on the bottom and split it up into two fractions. And then we get some canceling that happens. All right, so notice this first fraction on the top has cosine B on the top and cosine B on the bottom. So those are going to cancel out. So we're going to end up with sine of A over cosine of A. Okay. And so my cosines canceled out up here. Over on this side, my second fraction, my cosine A's cancel this time, and I end up with sine B over cosine B. Does that make sense so far, how I was able to cancel both of these fractions and reduce a little bit? On the bottom, the cosine A cancels with the cosine B, and cosine A cancels with cosine A, and cosine B cancels with cosine B. Everything cancels. So what should I put down here? I'm going to put a 1. right? When everything on the top cancels with everything on the bottom, you get a 1. And then on this side, I've got sine A over cosine A, and I've got sine B over cosine B. Well, that's a good question. How do we know what to multiply it by? Well, basically, you guys probably wouldn't, okay? So we're just proving the formula. You won't need to prove the formula. You'll just need to be able to use the formula. It's a good idea to know where that formula came from so you don't think it's just some sort of magic or something. Okay? But you won't need to be able to do all these steps by yourself. Okay? So what are we noticing? We have sine A over cosine A. That's just tangent A. So we have tangent A minus, here we have sine B over cosine B, and that will be tangent of B. So the top is just tangent A minus tangent B. On the bottom, we've got 1 plus the tangent of A times the tangent of B. Okay, so this is going to be the formula, well, one of the formulas. Okay. We also have a formula for the tangent of A plus B. I'm not going to go through all those steps again. I'm just going to tell you what you end up with. On the top, you have the tangent of A plus the tangent of B. And so all I did was I changed the sign on the top, and I'm also going to change the sign on the bottom. So on the bottom, I get 1 minus the tangent of A times the tangent of B. Any questions about any of that? Okay, now I'm going to try and figure out the tangent of pi over 12. So I think we might have done an example with pi over 12 in it yesterday. The pi over 12 is 4 pi over 12 minus 3 pi over 12. Right? Now, those do simplify nicely. So this is equal to the tangent of pi over 3. Right? If we cancel the 4 on the top with 4 on the bottom, we're left with pi over 3 minus pi over 4. So we're trying to figure out the tangent of pi over 3 minus pi over 4. So I'm going to be using this formula right here for the tangent of A minus B. Okay, so we're going to get, for the top, we'll have the tangent of pi over 3 minus the tangent of pi over 4. And then we need a fraction bar. Let's see if I can put in a fraction bar. Not bad. How did I get the first step? How did I figure out that I wanted to do 4 pi over 12 minus 3 pi over 12? Well, I just needed to think, what are some values, kind of the major values from the unit circle that we know the answer to? And we know the answer to pi over 3 and pi over 4. So I wanted to think, well, how would I possibly put them together to get a pi over 12? And if we subtract 4 pi over 12 minus 3 pi over 12, that'll make 1 pi over 12. Okay? So basically just thinking about the special values from the unit circle and how you can put them together to come up with the value that you're looking for. Okay, so let's see, we've got a tangent, my A is pi over 3, so I have tangent of pi over 3 minus tangent of pi over 4, and then on the bottom I have 1 plus the tangent of pi over 3 times the tangent of pi over 4. And then I need to start thinking about, well, what are these values? And the tangent of pi over 3, that's the square root of 3. The tangent of pi over 4, that's just 1. So that's the top of my fraction. And then on the bottom, I have 1 plus the square root of 3 times 1. And we can't really simplify this very much. I guess I could get rid of the times 1, and I could write it as the square root of 3 minus 1 over 1 plus the square root of 3. Are there any other questions that you guys have about anything? We're right at the end of 6.2, and we'll take a look at 6.3 tomorrow. Okay. If you guys didn't have any questions, then I will see everybody tomorrow. I hope everybody is being safe and healthy. Remember, you do have homework on MyLab. You also have a quiz to work on. A couple people wanted to take a look some more at 6.5, so I did go ahead and open that back up so you can work on some more on 6.5. Thanks for coming, and I'll see everybody tomorrow, I hope. Bye.